Throughout this unit, we're going to be taking a look at geologic time and essentially take a trip back through geologic time and see what took place on the Earth. Our first section in this unit is on fossils, and we're going to start today with looking at a brain pot.
You found a fossil? Hey, why are you digging a hole in the backyard? I don't think that's a fossil. I think it belongs to the Rottweiler next door. Dear Tim and Moby, what makes something a fossil? From Ross. Well, a fossil is a remnant of an organism. Usually, fossils are at least several thousand years old and found in the ground. Not every organism gets fossilized after it dies. As a matter of fact, it's a pretty rare occurrence. Fossilization has to start off with the right circumstances, like a quick burial. This is a body fossil, a part of the original organism that's been preserved. It's a bug that got trapped in amber, a type of sticky tree sap. Over time, the sap hardened, and we were left with this little keepsake. Body fossils are usually found in places where bacteria, insects, and the other things that cause decay aren't able to thrive. They form when an animal dies in the desert, or gets frozen in ice, or, gets trapped in a tar pit. Yeah, well, body fossils are really rare. Trace fossils, like these footprints, are the most common fossil type. Trace fossils can include animal tracks, nests, bite marks, and even animal poop. Other types of fossils form when an animal dies and is immediately covered by earth, mud, or sand. The covering slows decay down to a crawl and eventually turns to solid rock. The hardest parts of the animal, stuff like bones, teeth, and shells, don't decay for thousands of years. When they finally do, they've left a lasting impression in the rock. That's a mold fossil, a hollow print. Sometimes, water will bubble up through the earth, filling a mold with minerals. Over time, the minerals harden into rock, leaving a cast fossil. A cast fossil looks just like the original bone or shell. Right, of course, there are also carbon-based fossil fuels. All of the oil, gas, and coal on Earth was formed from the remains of fossilized plants and animals. For example, way back, like 300 million years ago, much of the planet was covered by tropical swamps. When the trees and plants that lived there died, they drifted to the bottom of the swamp. There, they slowly decomposed and formed a soggy, spongy substance called peat. Eventually, the peat got buried under layers of dirt and rock. Heat and pressure took their toll, and after millions of years, the peat turned into coal. Anyway, we can learn a lot from fossils. By looking closely at the fossil record, we can discover when and where lots of different organisms lived. In fact, we can learn about the entire history of life on Earth. Oh, the fossil record is just a fancy term for the sum total of what we know about fossils. Yeah, that's not going to work. It has to be under extreme pressure for millions of...
There are many definitions for fossils. Here's one. The definition says that a fossil is an impression cast, original material, or track of any animal or plant that's preserved in rock, usually sedimentary rock, after the original organic material is transformed or removed. A fossil can be a few different things. It could be an original skeleton or an original shell. It could be a mold or a cast of a living thing, material that has replaced the once living thing, or traces such as footprints or worm tubes. There are several conditions that promote fossilization. First of all, having hard body parts such as skeletal bones or exoskeletons promote fossilization. Also, very rapid burial and or lack of oxygen. There are a few different fossil types that we look at, two main types. One is body fossils, which are the actual parts of an organism, altered or unaltered, like bones, shells, leaves, or imprints. And a trace fossil, which is evidence of life that's not a body fossil, so things like casts, tracks, and burrows. Now we're going to watch a quick little video on how things become fossils.
It takes a rare set of circumstances to turn a living creature into fossilized bone. In the case of Lucy, the famous hominid fossil, discovered in Ethiopia's Great Rift Valley in 1974, there is no evidence that she met a violent death. No predator or scavenger found her body before it began rotting in the lake's soft sediments. Her bones, which settled in the mud, may have been cracked or shattered by animals roaming around the shore. Heavy rains gradually washed in enough sand and gravel to bury her bones. These deposits built up over thousands of years, burying her remains hundreds of feet deep. The calcium in her bones, molecule by molecule, was replaced by minerals from these deposits, ultimately turning the bones to stone. She remained buried over millions of years, while the Earth's crust moved constantly, forcing the remains of her body closer to the surface. Heavy storms beating down on the Earth eroded the sediment, and most likely brought her once again to the Earth's surface. Her exposure made it possible for anthropologists to later discover her remains some 3 million years after her death.
So remember, we have two main types of fossils, body fossils and trace fossils. And here are a few examples of body fossils of plants, animals, and other organisms. And here are a few examples of trace fossils. You can see we have impressions over here of footprints or leaves. Over here we have impressions of the shell of an organism. And here we have what's called coprolite, which is fossilized animal poop. We have several different modes of fossil preservation for body fossils. One category would be unaltered, and there are several different types of unaltered body fossils we could have. One would be actually having the original material, original and unaltered. The other would be incrustations or entuvements. For example, when you have material that gets trapped inside some sort of coating like amber or tar. Mummification, which is very quickly dried material. Refrigeration, which is material that is trapped inside ice and the tissue gets preserved. Tar, when organisms become trapped in tar, which seeps into their bones. Permineralization, which is when the pores in the tissue are filled in by minerals. And replacement, which is the replacement of tissue with minerals. And then the last one is petrification, which is a combination of permineralization and replacement. And then lastly, we have carbonization, which is when the tissue material decomposes or is reduced to just a film of carbon. And your book talks about this and calls this carbon film. And then we have a few different types of trace fossils. We have a mold, which is a reproduction or an imprint of the inside or outside surface of a living thing, like we see on the bottom here. And then we have a cast, which is a duplicate of the original organism, usually formed by replacing the inside of the living thing. So like what we see up here, where we might have started with a mold and then it was filled in with another material. Another type of trace fossil would be a burrow or boring, which are spaces dug out by living things and then preserved as they are or possibly filled in. Gastroliths are smooth stones that some types of dinosaurs would consume to help them digest their food. And coprolites, which I mentioned before, which are fossilized excrement, and usually these are preserved by replacement. And then the last type of trace fossil that we have are tracks, which are impressions of the passage of living things. Often we see these as footprints. We use the fossil record for some very important things. We use it as evidence to the history of the Earth, and also to see how organisms have changed over time. The fossil record supports the theory of evolution, which is the gradual change of an organism over time. Millions of types of organisms have evolved over time, and most of them have become extinct in the process. What is extinction? It's when a species is no longer living on the Earth. And 99.9% of all species that have ever existed are extinct. We also use fossils to determine past environments. So from this example here, you can see 3 different types of fossils that indicate 3 different depths in the ocean. Here's another example of fossils living in different environments. This is a modern-day landscape, and here we see on the land, we see the types of fossils that we might find from this environment, like pollen grains and elk skulls. Here, from the beach environment, we might see some pollen grains, but we might also start to see some clamshells there. And then from the deep ocean, we would see clamshells and shark teeth. So the types of fossils that we find indicate the past environment. And that's it for this video on fossils. Stay tuned for the next one on relative dating.